91290 with you to bring you another risk analysis. A severe thunderstorm threat exists for July 17th, 2025 for mostly the mid-afternoon to the early evening period. So stick with me to the end of this video and I'll show you the target areas in question and the hazards associated with these types of thunderstorms in the given environment. So without wasting any more time, let's get right into it. Okay, so looking at surface moisture convergence, it's measured in grams per kilogram per second. So this offers an evaluation of how strong lift or ascent would be ahead of any frontal boundary. In this case, we want to evaluate the strength of our cold front. So the best way to do that is to look at surface convergence. So this is during the early morning period, and we're seeing some larger amounts of lift taking place as represented by these yellows to ambers. So I would expect isolated thunderstorms to already start appearing during the morning period. Now let's backtrack 3 hours. And even during pre-dawn, we are seeing some brighter colors taking place. So even during pre-dawn, I would expect these to favor some thunderstorms in eastern Ontario to southern Quebec and portions of the northeast, like in upstate New York, western New York as well. So let's go further towards the afternoon. Notice these brighter colors really taking place in eastern Ontario to southern Quebec, upstate New York, and then going deeper. Now all the way to the late afternoon, you're seeing these brighter colors, especially around the island of Montreal. Notice these blues representing the highest amounts of lift in this situation. So we are seeing these really high amounts of lift taking place in eastern Ontario, southern Quebec, and much of the northeast. So I think this will be an area to really watch during this time frame from the mid-afternoon to early evening. Looking at lift at the 500 millibar altitude. So this is vertical velocity measured in microbars per second. So here, this gives us an indication of how much lift is taking place with any shortwave trough or impulse that might be present. So now we're at pre-dawn of July 17th, so not all that much taking place in this general area. But as we go deeper into pre-dawn, you start seeing these smaller areas, these smaller zones of ascent that are taking place in southern Quebec and parts of the northeast. So this could offer some opportunity for some pre-dawn thunderstorms, although I expect them to be mostly isolated. But let's go deeper into the morning. And then going more into the afternoon, you start seeing larger areas of lift associated with our potent shortwave trough that's trying to come through from the northwest and sliding somewhat southeast or east-southeast. And I think these are going to be mostly the focus for stronger thunderstorms and larger groups of thunderstorms to appear in this general area, especially in eastern Ontario to southern Quebec. Now notice how this zone pretty much slides to the north of the island of Montreal, so it's most likely that we'll see some of the strongest thunderstorms just north of the island of Montreal, or northwest, and going to the north, although this does not exclude the island of Montreal, since again we are seeing large amounts of lift from our cold front. So this area here, I think, will be an area to watch during the mid-afternoon all the way up to just a little past sunset. Okay, so looking at CAPE, so this is convective available potential energy. It's a metric for instability. So the greater the value, the greater the amount of instability. And this is for 5 p.m. on July 17th, and we're seeing these brighter colors appear, which represent particularly high CAPE. So the yellows to ambers represent CAPE values of 3,000 to 4,000 joules, and eastern Ontario to southern Quebec, we're seeing values as much as 2,500 joules per kilogram. Now, I'm willing to say that this could reach or slightly exceed 3,000 joules per kilogram, but this is difficult to do because, again, we're not seeing those steeper mid-level lapse rates. So for 5 p.m., this is pretty high. And let's go one time step further into the late afternoon, so approaching sunset, and we're still seeing values close to 2,000 joules per kilogram around the island of Montreal and extreme east Ontario and portions of the northeast where that's still holding on. And then one more time step towards late evening, so around 11 p.m., we see that this zone of CAPE starts to evacuate off to the east. So we're not seeing all that much taking place now for most of the areas farther west. So our risk will start diminishing very quickly as we go deeper into the evening. So this is for 2 p.m. on July 17th, and we're seeing some fairly steep rates. So these represent rates of about 7 to even 9 degrees Celsius per kilometer. And going deeper into the afternoon, we're still seeing those barely making into eastern Ontario to southern Quebec and much of the northeast. Into the early evening, still hanging on barely at about 7 Celsius per kilometer. So this represents fairly steep low-level destabilization, mostly because the sun is able to get through in this very moist environment. Okay, so now looking at our mid-level lapse rates, we're not seeing all that much here as compared to our low-level lapse rates, which was really decorating this map. But for July 17th, so this is late morning, 11 a.m., and then going forward into the afternoon, we're not really seeing all that much contribution from mid-level lapse rates to help further destabilize the air. So I think this will be a limiting factor for instability altogether. Okay, so pulling up a skew T log P diagram for the Montreal area, so this will be our sample point for July 17th at 5 p.m. So I skip right ahead to 5 p.m. because that is within the time range where we would expect the strongest thunderstorms to appear and also the greatest number of thunderstorms to actually appear. So that will be ahead of our cold front, as we showed before, as well as our potent shortwave trough. Now let's look at some attributes very quickly. So first I want to start with the shearing profile. And so within the boundary layer, we have this veering component. And what do I mean by that? So at the surface, we're seeing the south-southeast wind field as represented by this wind barb in terms of how it's pointing. So it's from the south-southeast at 1000 millibars, which is where we are, and going all the way up to about 1.5 kilometers in altitude to about 850 millibars, we're seeing the winds becoming southwesterly. So you go from a south-southeast flow to a southwesterly flow over time. And notice how the wind speeds are increasing quite rapidly with increasing altitude and becoming mostly unidirectional thereafter. And another attribute is notice how strong these winds become at roughly 500 millibars. So this is roughly the mid-altitudes of the troposphere. And we're seeing this strengthening wind field taking place, this west-southwest wind field that's present with us by 5 p.m. A little bit earlier than 5 p.m., I would expect this to start taking place as well in these regions from Eastern Ontario, Southern Quebec, and the Northeast. If I skip one time step ahead to go towards 8 p.m., so late afternoon, closing in on sunset, let's look at the wind shear profile. Look exactly what happens here. So we're seeing a magnified and a strengthening shearing field, including a directional component that's taking place. And look how quickly the winds increase within the boundary layer. These are really, really fast wind speeds for at and near the surface late afternoon. So getting close to sunset. So we're seeing these really strong shearing fields taking place. So this could represent a good influx of moisture getting into our thunderstorms and the presence of a low-level jet that's taking place to amplify these wind fields at this time within our warm sectors. So that is another important attribute that's affecting how much shear is taking place. And still some very strong shearing profiles at the 500 millibar altitude. Okay, so going back to 5 p.m., just very quickly, look at our instability factor. You can see it's distributed over a gray tropospheric depth. So this gap that's actually taking place between this red curve, which is our environmental temperature, and this dashed blue curve, which is our parcel temperature. So anything in between there represents instability. It amounts to about 2,700 joules per kilogram. I'm willing to say that we could approach 3,000 joules per kilogram. But it's very difficult to exceed that amount since we're not getting that much in terms of mid-level lapse rates. So I think this is a pretty good estimate of what we would get as a maximum. Considering this instability factor, considering the shearing profiles, what this screams out to me is that these thunderstorms will be capable of strong straight line winds. I think this will be the most important hazard with these thunderstorms altogether. Locally, these winds can be damaging. And at the same time, I think what feeds into that damaging wind hazard is this rapidly decreasing moistening profile. So the dew point temperature is represented by this green curve, and what this plot shows us is how quickly that dew point is changing, or how it's changing altogether with increasing altitude. And you can see here that it's decreasing pretty rapidly. So this is what we call a hydrolapse. So a sudden or very quick change or decrease specifically for our moisture content, and it is showing a rapid drying that's taking place. Since dry air tends to cause more evaporative cooling within thunderstorms, which amplifies the risk for strong straight line winds because of stronger downdrafts. Now, just quickly, you can see that drying profile. This is now back to 8 p.m., so we're one time step forward. Notice how this drying profile is amplified, and notice that straight line wind hazard is becoming more important during this time. So especially between 5 p.m. and 8 p.m., I would look out for thunderstorms racing very quickly. So again, these profiles also suggest that thunderstorms will be very fast moving. Now, the other factor I want to point out is this rather warm 500 millibar temperature. We saw it in the 5 p.m. profile as well, but just to look at it here, we actually see that the temperature is quite warm at -3 Celsius. So this represents a fairly warm environmental temperature at this altitude. And I think what this is going to do is perhaps limit lightning frequency with many of these thunderstorms. So I don't think we're going to see the extent of lightning that we saw on July 13th during those flash flooding thunderstorms, but I'm still willing to estimate a moderate lightning frequency with most of these thunderstorms altogether. So based on the location of the strongest amounts of lift, I expect thunderstorms to be forming in scattered to widespread fashion within this zone. So I do expect them to be moving pretty quickly in this sort of fashion, especially during the mid to late afternoon when the greatest number of thunderstorms should appear in eastern Ontario, much of the northeast, and southern Quebec, ahead of that cold front and that potent shortwave trough as both those features start to migrate to the southeast in particular. Now, the principal hazards would be mostly strong straight line winds, partly owing to this fast movement, as well as the dry mid-level air that I showed previously. So I think I'll stress again that the strong straight line winds will be the primary hazard. Also, there will be an opportunity for isolated weak tornadoes before thunderstorms have the chance to consolidate into larger families. So many of these thunderstorms, before they even group together, they will be somewhat discrete, semi-discrete, and at that point they will be capable of a weak tornado in eastern Ontario, especially to southern Quebec, where that lift is particularly greatest. Now, as we saw with the 500 millibar temperatures, as I showed in this same zone, these temperatures are fairly warm for 500 millibars, so I do expect lightning frequency to be somewhat modest. I don't expect it to be particularly significant like what we saw on July 13th, but they still will be capable of moderate frequencies at best for most of these events. Now, a few of them may be able to achieve higher frequencies, but in general, I expect lightning frequency to take on moderate status, low to moderate. Now, for the same reason, I also suspect that hail production will be similarly limited because of those warm mid-level temperatures. I don't expect hail to be a particular hazard with these thunderstorms as much as the straight line winds, and rainfall itself will be significant. But because of the faster movement of these thunderstorms, I don't expect flash flooding to be a concern for most of these areas. But again, I do stress that they will still be capable of significant short duration rainfall rates. Now, the lift, although not as great as the mid-afternoon to early evening, I do expect isolated thunderstorms to be forming in eastern Ontario to southern Quebec, where we do see some increased convergence taking place and even some pockets of higher lift at the 500 millibar altitude. So these areas, I think, will have some isolated thunderstorms taking place during pre-dawn to early morning as well, and then this number will increase into a scattered to widespread sort of distribution. So if you made it this far, thank you very much for your attention. I always appreciate your attention and your viewership. If you found this video useful, if you found it insightful, smash that subscribe button so you do not miss out on upcoming videos, upcoming forecasts, and upcoming thunderstorm documentations from the Montreal area and the Orlando, Florida area. So if these are things that interest you, I encourage you to subscribe so you do not miss out on upcoming footage and content. And until then, I will see you in the next video. Once again, thank you for being such awesome listeners. I really appreciate it, and I will see you in the next video series. Cheers.